Okay, well, let's start this time. So welcome to the webinar Ultra High Power Modules, how inverters manage high power per string and achieve LCOE reduction. So welcome to our webinar. Today we'll have three experts, Antonio Jimenez from Trina, Yu Sheng from Huawei, and Omar Al-Darvish from SMA, talk about different aspects of ultra high power modules and inverters, how they work together. So today, just for those of you who arrived a little bit late, we will definitely be recording this session, and you'll get an email with the recording and the presentation slides probably early next week. And also remember that this is your chance to ask questions through the questions and answers box, which is at the bottom. And finally, well, we have a tradition here at ATA Insights. We, through the chat box, we ask people to say where they're joining from. So I am actually in Poland right now. So and my colleague Anna is in Spain. And so yeah, just join the chat box and let us know where you're connecting from. So I think now we'll get started. Anna, so you can, thank you very much for stopping sharing. So right now I'll ask each of the panelists to introduce themselves. So Omar, would you like to start with introducing yourself very briefly? So.
Definitely. Good morning, good evening, and good afternoon, everybody. So my name is Omar Darwish. I'm an applications engineer at SMA. I generally cover large-scale PV and storage applications, and I'm very excited to be presenting today alongside Antonio and Steve.
Thank you very much, Omar. And well, Antonio, I see you've, you want to go next, so go.
Thank you very much, Carlos. This is Antonio. I'm responsible of Trina Solar for Middle East and Africa for all the product and solution. Thank you very much.
Thank you, Antonio. And last but definitely not least, Steve, would you mind introducing yourself very briefly?
Yeah, I'm Steve. Now I'm in Shanghai, and I'm responsible for the Huawei R&D for the technology and the innovation of the inverters. So today I was talking about like the inverter, how to compatible with the Ultra, like the higher power modules. Yeah, thank you very much.
Thank you very much, Steve. So right, so well, once again, welcome everyone. I think right now we can get our first presentation started. So Antonio, over to you whenever you want. And whilst Antonio is getting ready, I'd like to remind you that you can ask questions through the Q&A box. So, just and then we'll answer them after all the presentations are done. Antonio, over to you. Oh, you're on mute, by the way. Sorry.
Sorry. Let me
start. Oh, there we go. Okay.
Hello, everybody, and thank you for your time. We'd like to present today the brief introduction of the new ultra-high power module of the 550 and 600 watts. So this is was presented lately. What is the new offering of Trina Solar as the most advanced products in the market? We are bringing to the market with, four products. Two of them are monofacial, two of them are bifacial. One is 550 watts, another 600. As you have seen, is with the new 210 cell. If we go for the capacity for next year, we will have already in 2020 a capacity of 10 gigawatts, which we will increase to 21 gigawatt next year and to 31 in 2022. So we see that this will be a really mainstream product for us in the market. So let's explain a bit how the module is built and the main characteristics. So the 550 watt module is a module which not only has a very high power, but also a high efficiency, reaching 21%. The base of this module is the cell of 210 millimeter, the largest cell currently in the market, and that one that provides a very high current. This is a module, I will say that it's longer than wider. We have two options, one is wider, the other longer. This reaches almost 2.4 meters long, which is almost the size that will fit in a container. So it will really optimize the logistics, and it has a width of almost 1.1 meter. The weight of the module, we are talking about around 28 kilos for the back sheet and 32 for the dual glass. It's still a weight that is manageable, that can be installed, not much different of previous modules in the market. And they have a series of characteristics with a cell that makes a very reliable product, but I will go in the following slide. These are the non-destructive cutting, the multi-bus bar, high density, and so on. One interesting characteristic of this module is that we depart from the traditional 144 or 120 cells. We are talking the module have 5 by 11 half-cut cell. So we are talking that 110 cells into circuits that gives a lower voltage. This lower voltage, we are talking in this module around less than 40 watts, around 38 volts, and gives to compensate that the current is very high or much higher than it was before, around 18 amperes for the monofacial. This characteristic, for example, the module still has the three diodes, so we'll have a very safe in terms of hotspots, and also it allows a very important characteristic that I will explain later, which is a very high power per string. The rest I will talk is the temperature coefficient, similar to many of the product of Trina Solar, has a very good thermal coefficient, and the warranties as good as the other Trina Solar product. We are talking about 2% the first year and 0.45 for the double glass for the next 30 years. In the case of 600, the characteristics are similar because it's a similar construction, similar cell. The only thing is that it's instead of 5 by 11, is 6 by 10. So it looks a bit more similar to a traditional module. In this case, the efficiency increases because it doesn't have the vertical connector that for having 6 because it has 6 cells. Going a little about more inside the module, I would like to explain that the advanced characteristic of this module, which makes the very advanced, which is the non-destructive cutting. This is a low temperature procedure without mechanical separation that, as you can see on the right side, gives the same mechanical strength as a full cell, almost the same, and much higher than other traditional methods. So when we are talking that this module is very reliable, is that the cells are as reliable, as strong as a full cell, as if it were full cells. Then the following is about the multi-bus bar. This is something that Trina Solar has been working in commercial modules for many years, which is that we replace the flat ribbon, which was usual when there were 5-bus bar, with a wire, round wire that reflects the energy back, the light back to the module because it's round and provides additional. Also, because there are many more bus bar, the distribution of temperature is much more equal, and it reduces the path of electricity, so it gives a higher power. Also, it's regarding the hot spots, it's also very safe product because it has they have 3 diode for many fewer cells, have very high quality cells, and it is a product that has less risk of hot spot than standard products. In terms of interconnection, the standard module will have a gap between cells of around 2 millimeters. We have reduced that to less than 0.5 millimeter, which allow us to have an efficiency of up to 21 or 21.2%, but without the loss of without a loss of yield because of overlapping the cells. So if you put a cell on top of another, of course the efficiency increases, but there are losses of energy because there is part of the cell which is shadow, which doesn't receive the light, and that reduces the performance. So the same module, if you choose a high density module instead of a module with overlapping, the yield will be higher. And then the main characteristic, the cell of 210 has a high power, and because it's so big, it has a low voltage. And this allows, most important thing, more power per string. The string at the end is what makes the basic subunit of the PV plant. And all the evolution of the power has gone into of performance has gone into higher currents, which means higher energy, because it's very clear. The voltage now of an inverter is 1500 volts as a reference. So we are adding up modules to reach VOC 1500 volts, operational around 1000, 1100. So we have the same voltage in the string. What, in order to have more power, we have more current. So is this means more losses? No, it doesn't mean more losses. What we are doing is that instead of 2 strings, what is more current? 2 strings of 9 amperes or 1 string of 18 amperes? It's the same. So since it's the same, losses are similar. So that is offtake. There are no more losses of current. What we have is more power, which reduces the VOS, and which determines the cost of the plants. How much additional power? So we have, for example, this is an example of 10 degrees. When we have, for example, in Middle East and Africa, places with warmer temperatures, we can reach to even 40 to 42. So we are talking about 20 to 22 kilowatts per string. This is a very high power, and this is monofacial, even higher with a bifacial. So compared with even the very advanced module currently is 35% more, 36% more, even higher, which this allowed to reduce the number of strings in the plant and to reduce the cost of the installation. How much are we going to reduce? Make an analysis, third-party analysis by DBL. We see that we reach in the US 6.5% in the VOS, and a LCOE of almost 3.8%. And this is compared with a similar module of more than 500 watts. Compared with a module of less than 500 watts is even higher. So this is a good advantage. The question is what we are going to answer today. Are these advantages realized? And for that, we are here today because there is it's not only us. It's a group of more than 70 companies that are working to develop all this range of product above 600 watts. Because one thing is clear, it's not possible to reach more than 600 watts with a smaller cell. You will need more than 80 cells to reach that. So in order to do that, you need a higher current. And in order to have a higher current, there are many products which can be used now. It is possible to install to use current inverters, current trackers, but with a further optimization, we will realize all the savings. And this is something we have a lot of companies working for that, and we are also discussing today also for the inverters. So let's see. So I would like to give the voice back to Carlos and also to the Omar and Steve to give their view.
Thank you very much, Antonio, for your presentation. Very interesting. So in between each presentation today, we'll have a poll. So, you know, if you can stop sharing, please, Antonio, and Anna, if you can share the first poll of today, that would be great. So here we go. I hope you can all read it correctly. So it reads, what power bin range will you expect to use the most in 2021? So we'll keep this question open for a few seconds. We'll do a countdown when we ask to stop it. And well, in the meantime, you know, whilst the answers are coming in, I'd like to remind you of the fact that you can ask questions. So send your questions through the Q&A box after you have participated in the poll. And also remember that we'll send you the recording of these sessions. So, right, so we'll keep it open for 3 more seconds now. So 3, 2, 1, and that's it. Right, thank you. Thank you very much. So, well, here you have briefly the results, and so now we're going to go to our next speaker today, who is Steve Zhang from Huawei. So if you can get ready, Steve.
Yeah, I'm here.
Yeah, so I can hear you well, and I can see your presentation on full screen. So okay. Please go ahead.
Okay, thank you. It's a great honor to attend this webinar event hosted by China Solar. So thank you very much for the invitation. And today I will talking about Huawei Smart PV solutions. And my topic is AI boost for optimal LCOE and grid support. Okay, next slide. And today it will be including 2 parts. One is for what is kind of solution for the 6.0 and plus. And the second one, it is what is the strategy with the high current modules from Huawei Site. Okay, next. And based on the understanding about Huawei, so Huawei provide Vision Solar smart PV solutions. And it is consists of inverter at the left side. This is our inverter. It's like a 185 kilowatt smart string inverter. And also the second product, it is the smart array controller. This is for the data transmission and control. And also the third one is the smart transformer station. This is also for the overseas market. This is integrated with LV cabinet and transformer and also the RMU. And for the smart PV management system for the real-time monitoring and also management. And today I would like to introduce our latest some progress, how we deploy AI technology in Vision Solar. Okay, next one. From the solution view for Huawei Site, we are insist on the multi-MPPT topology design for our inverters, which brings the maximum benefit to customer by reducing the stream mismatch and improve the energy yield. For the 185 kilowatt inverter, so it is integrated with 9 MPPTs and with 18 inputs. So 2 stream parallel together to reduce the stream mismatch. Accumulatively, Huawei had delivered 130 gigawatt shipment by the end of first half year of 2020. Based on the customer real-side test, so here is all the data that is we are tested with our customers. So the generation by the string inverter, so it is at least 2% higher than the traditional solutions. Okay, next one. And also this is the deployed by AI. What is we are calling is smart DC systems. What is the meaning of DC, smart DC? So the tracker, it is connected to the smart inverter, and the tracker angle is optimal and control based on AI algorithm. This is closed loop control. After doing this control, the tracker we are running at a different angle according to the tracker structure status, including the shading, unflagged line, different reflective material, and the operations. So by doing so, the tracker will ensure the panels working on another level MPPT. So this is the tracker level, not the inverter level. This is without any additional cost to do so. It is just like the older tracker system is connected to our inverter. Then inverter deliver all the data and also the signals to the SCADA systems. So in 2019, we did some tests at several sites in China. The introduction by this AI algorithm increased the generation yachts by 0.5 to 1% by these smart DC systems. Okay, this is for the smart DC, and now going to the another powerful AI technology is smart IV curve diagnosis. So this is for Huawei, the third generation already in the last 6 years. In the first video on the left, this is the manual inspection. It is impossible to perform like IV curve diagnosis for all the string in a large scale PV plant. The O&M staff is only able to inspect 1% to 3% of the PV plant, and it takes another like 3 days to complete the analysis and come up a report. But on the right side, this is by Huawei. We are calling smart IV curve diagnosis, helps to diagnose like a 100 megawatt PV plant within 15 minutes to generate a report automatically. This is online diagnosis without plug out all the streams from the inverters. Here, it will take around like 1 gigabyte data in 100 megawatt PV plant for self-learning based on AI. AI will learn it and come up with a report to share indications like what kind of which module and which strings we need to do like the troubleshootings. It helps us to know the health of PV plant, and furthermore, it will lead to higher generation after doing the collection and the troubleshooting according to the diagnosis report. So this is also based on AI to do the smart IV curve diagnosis to increase the O&M efficiencies. Okay, next one. And this technology is for the data transmission. What we are calling is MBUS. So for the MBUS, it is consists of 2 important components. One is Huawei own high silicon chipset, and the second one is Huawei IoT operating system. Based on this technology, so all the data will have a faster way to do the transmission. What is the effect? Firstly, like the transmission distance is more than 1 kilometer. It can support maximum capacity of subarray up to like 15 megawatt. Secondly, the transmission speed, it is reached 115.2 kbps. So it is 15 times of RS485 cables. It doesn't need additional RS485 cable. Like before, when we do like doing some the communications, wiring all the inverter and all the DC combiner box by the RS485 cables. But now we no need any cables. It is just to using the AC power cable to do the communications. After the traditional RS485 cable is eliminated and not used, which not only saving material and the manpower cost for the RS485 cable, but also enhance O&M reliabilities. This feature is the foundation of all the AI implementation, which require fast and reliable data transmissions. Okay, so this is for the MBUS. Go to next slide. A part of that, so we are talking about the grid support. As the ratio of the renewable increase, now like the solar and also the BSS now is very popular. And with the application also with the new HVDC and the HVAC system, the impedance of the power grid will change accordingly. For example, like if today your PV plant is safe and not impact on the grid, but several years later, after the solar is more and more, and especially injected to the some like all the pure plant is injected to the same POCOM point, it will lead the pure plant have another potential reliability issues. Now we needed a solution to support grid and adapt to the impedance changes through the AI self-learning algorithms. This unique AI self like the learning prepare the pure plant for the future, even then the ratio renewable energy increase. So now at the right side, so for Huawei, now for our inverter, so it can do support minimal the SCR. SCR, what is meaning is the short circuit ratio can go into 1.5. So this is means like, for example, like in Australia, like in China and also in Spain. So inverter, when we connect it to the low SCR of the some environment, so it is safe and also reliable. So this is the what is where we are going. So we want to our inverter is more friendly to the grid and let the have more space to connect the grid. Okay, so going to the next slides. So all the above is talking about some of our key feature for the smart PV solutions. And now we are moved to the product strategies for the high current modules. Next. From the electrical parameter view, no matter like the maximum power and the current voltage, this is fully matched with our new 185 kilowatt in Middle East. So the MPPT current of our inverter, each MPPT is up to 100 ampere. It is very flexible to maximum. It can connect 5 strings and large current modules. This is means like per MPPT, we can maximum to connect like 5 strings. And for our inverter, so also this is the maximum for the string quantity. It is 18. So this is means from the inverter, this is a new model, but also it is compatible with the maximum current of the PV panels. Okay, let's go into the next one. Now we are taking the Vertex as an example. So consider like for the globally, like a lower temperature, like from the some like a minus, like a 20 degree or 5 degree or like 4 degree. So we are do some calculations using like 550 or using 600 watt. So for when the inverter is connected 15 strings, so the DCAC ratio maximum it can go into 75% of the DCAC ratio. So it is means it can for this inverter it can support large DCAC ratio, and also it can match with the China Solar, that the Vertex of the PV panels. Okay, I think that's all for my presentations. Thank you very much.
Thank you very much, Steve, for your presentation. So I think we'll now get ready for another poll. So Anna, whenever you can launch it, and I can see that you have been sending questions through the Q&A box, so we'll answer as many of them as possible on the after the third presentation. Here we go. Here is the poll. I hope you can all see it. So it reads, which of the below you consider the most important decisive factor for PV modules when designing a plant? The options are efficiency, module power, power degradation, bifaciality, weight, or other. So we'll let the poll run for a little while, so they can, as many people as possible can participate. And well, in the so those are your options there. It seems that efficiency is regarded as the most important factor. So we'll keep it open for a few more seconds, and that's it. So start a countdown now. So 3, 2, 1. There we go. That's it. Right. Well, so these are the results of a poll. So efficiency is the most important factor, followed by module power. So let's continue with our presentations today. So next is Omar Al-Darvish from SMA. So Omar, when you are ready, please start your presentation.
Well, thank you very much, Carlos. Basically, let me just get this set up real quick. Perfect. You all can see my screen?
Yes. Yeah, it looks perfect.
All right. So I'll focus today more on basically the topic at hand, which is inverter compatibility with ultra-high power modules. And I'll take more of a technical route during the presentation. But at first, I'll just some quick figures about SMA. I'm pretty sure you're familiar with our company. We've been in business for 35 plus years. Right now, we're 3,000 employees strong. We've got around 95 plus gigawatts of installed capacity in 190 countries and about 1,200 granted patents. In terms of financials, we've just released our H1 report for 2020. Despite the coronavirus pandemic, we're still going strong, actually expecting significant growth in sales and in inverter capacity as opposed to last year where we shipped around 11.5 gigawatts. Well, in the first half of 2020, we already shipped around 7 gigawatts of inverters. For those of you who are not familiar with our product portfolio, we cover basically the full range, from residential through commercial to utility, with battery and PV inverters, with power ranges ranging from 1.5 kilowatts up to 4.6 megawatts in a single inverter. Enough of the marketing talk. I'll just quickly tell you what we're going to be discussing today. So what I'm going to attempt to do in these very short 15 minutes is basically discuss the module fundamentals. So what is really the scientific, let's say, fundamentals behind these ultra-high power modules that you're seeing on the market today. And mainly we're going to be discussing short circuit and operating currents. We'll then discuss the implications of such high currents on inverters in general, and specifically on the module inverter interface, which is the MPPT. And finally, we'll discuss or showcase compatibility of these high current modules with current SMA inverters. Taking you back basically to PV 101, this whoever has taken a PV course or maybe has attended a presentation, this is basically what the manufacturing process of a PV module looks like. You basically get silica, you purify it, crystallize it, you get an ingot, you slice it, you produce a wafer, you then maybe etch it, dope it, you get a cell, you assemble the cells in a module, and you got a system. What we've been seeing basically since the mid-1990s all through the early 2000s, all the way to 2020 is a clear trend of growth in wafer size. In the literature, you'd see these basically as their names as around like M0, M3, M4, M6, if you're reading an article on PV Tech or something. And these are the most popular, or they have been the most popular for the past decade and a half. So the M0, which is around 156 millimeters in size, all through to M6, which is around 166 millimeters in size, are responsible for like the 300 watt peak modules, whereas the newer introduction of the M10 and M12, which can go up to 210 millimeters, which is the wafer being used at the Vertex module, are being used to generate basically modules with 500 and 600 watt peak of power. To understand where this comes from, you really need to take a step back to basically the physics. I mean, here's a cross-section of a normal PV cell, and basically what a PV cell is a current source. You've got some light coming into the top part. Basically that's a beam of photons. A photon would knock over an electron. The electron will be collected and then goes through the circuit. The number of electrons being generated is directly proportional to the irradiance. So basically you can model a PV cell as a irradiance controlled current source. You can increase this current by increasing the irradiance, or if you keep the irradiance constant and increase the cell area, you'll get also more current. So larger cell area, more photons being bombarded on the cell, larger current. One might say then, but aren't these cells cut in half? Specifically, the Vertex module is using half-cut cell technology. Well, you'd expect half the current really if you're doing half-cut cell technology and you're stringing all of these in series. So you basically cut the current in half and see double the voltage. But what usually manufacturers do is basically when they cut the cell in half, they cut also the module in half, and you get, instead of, let's say, 120 half-cut cells in series, you get 60 on each side in parallel, keeping the voltage and the current constant even when you cut the cell. Regarding bifaciality, it's modeling the behavior of bifacial cell is quite straightforward. What you're doing with the bifacial cell is allowing albedo irradiance to hit the cell from the backside. You can then model it as a monofacial side by transferring the irradiance that's going in from the backside towards the front side. But of course, the efficiency at the backside is different than the front side, and the ratio between the two is what's known as the bifaciality factor. So if you have a situation where you have 1,000 watts per meter squared on the front side, 200 watts per meter squared on the backside, then that would be equivalent to having around 1,160 watts per meter squared on the front side. So higher also, so bifacial means plus larger wafer cell means more and more current in terms of I short circuit and IMP. Going back to this graph right here, these are the values you've been all used to in the past decade. Talking M0 to M6 are typically have around 10.5 amps of short circuit current, while the newly introduced M10 and M12 can go up to 19 amps of short circuit current. So what does that really mean for inverters? At the DC interface, we really we need to look at two values. So I mean, for wafers, you're looking at IMP, which is your maximum power point current, and your short circuit current. While as at the inverter, you're looking at the operating current of the MPPT, whether it's a multi-MPT inverter or a single MPT inverter, and you're looking also at the short circuit capability of your inverter. I'll discuss quite quickly what these are. So short circuit current is basically as it pertains to the inverter, is basically the ability, the maximum current that your DC to DC converter can accept. It's generally a worst case calculation. So when you're matching your short circuit current from the modules or your array towards your inverter, in both the single and multi-MPPT case, what you need to do is you need to assess how much short circuit current your module is producing at the maximum temperature irradiance combination. Right? So you look at the spectrum of temperature, you look at the spectrum, distribution also of your irradiance on site, and you pick the worst point and you say, okay, I can't have I can't have as many strings, or basically as many, or this specific module that has short circuit current more than what the inverter can accept. The operating current is a different story, is more stochastic rather than worst case scenario calculation. Right, so you can basically have a scenario where your module is operating below the maximum operating current of the inverter, and that would mean I'm extracting the maximum power from that string or from that module. And you can have another scenario here in blue where the maximum operating current is actually below the IMP of the module, and that is basically what we call clipping. So clipping is you're actually clipping the modules or the strings current. What do I mean by stochastic calculation? Well, if you're oversizing your array, you're definitely going to exceed the operating current of the inverter. This is some data, actually some field data from two plants in Jordan, courtesy of our friends at Mustaqbal, that have been in operation for quite some time. It shows the distribution of the maximum port current of the array throughout the year. And you can see that actually for most of the time, even for tracking systems, the current coming from the modules is well below the STC value on the data sheet. That is because you've got light-induced degradation, you've got soiling on site, the air mass and humidity should be taken into account, your azimuth and the tilt of your modules, as well as shadowing. Finally, how do SMA inverters come into the picture? In terms of utility scale applications, we tend to go for single MPPT inverters. We believe that is the best solution there. And of course, as it pertains to string and central inverters, I'm just going to discuss string because the central option is quite arbitrary when it comes to currents, because then you're connecting maybe hundreds of strings to that bus bar. So in terms of our string inverters, you've got the 1000 and 1500 volt variants that come at 100 and 150 kilowatt capacity. And with the 550 and 600 Trina Vertex modules, you can actually go up to 2.4 DC to AC ratio. One typical, or let's say one problem that you might face and you need to look at is the fuse sizes on these DC combiner boxes. There are 25 amps or 30 amp fuses are readily available on the market. So you just need to look out for your fuses. And basically what single MPPT inverters provide is a future-proof solution, right? So that same inverter can be connected maybe in the future to 700, 800 watt peak modules. All you need to change are some few components on your combiner box. Actually, the larger currents from the DC side create a better opportunity for optimization. So basically, on in terms of positioning, right? So in a single MPPT structure, you've got 2 degrees of freedom. You can move this DC combiner around, as well as the inverter. For higher currents, you would assume that the DC combiner would move more towards the modules due to the higher cross-section of the cables coming from the modules. The decentral architecture, this is what we call decentral architecture, enables compensation of your DC losses, basically that are coming from the higher currents, by actually vamping up your DC to AC ratio. And just as a side note, SMA inverters do allow you to go beyond 1.5 DC to AC ratio, up to 2.5 even. But these need to be assessed. That depends really on the site conditions, but need to be assessed on a case-by-case basis. But basically, if you're vamping up your DC to AC ratio, you're using some energy from the modules themselves to transfer the energy to the inverter, and then you're not paying for the AC losses throughout the day. We tend to disagree on the mismatch losses due to string versus, single versus multi-MPPT inverters and utility scale applications, where we think you cannot gain more than 0.5, 0.6% in yield by using a multi-MPPT inverter. That being said, for, let's say, smaller plants, let's say large commercial on the order of 1-2 megawatt peak, this is a quick assessment of the compatibility of our multi-MPPT inverters with the Vertex modules. You can see here to the right, actually, the worst case short circuit current from the bifacial and the monofacial. We've been very generous with the conditions, 20% rear side irradiance, 70 degrees worst case temperature, and basically STC irradiance. And you can see that most of the inverters, all of the inverters are already compatible. Some do not give you as much flexibility. These the 10 kilowatt, I'm not sure if it's even applicable for such high power modules, but still you can go up to 3.5 basically on a 15 or a 20 kilowatt inverter. Finally, some things to look out for really when you're using such high current modules with multi-MPPT inverters is basically, first thing is you need to look at the string rating versus the MPPT rating. On a data sheet, typically you'll see the short circuit current of an MPPT, but that doesn't necessarily mean that a single string can handle that short circuit current. So you need to double check that. Some manufacturers also limit the power per MPPT. So that would lead to really extremely high clipping losses if you're using such high string power on your MPPTs. And finally, some actually ratings are voltage dependent, so you need to take care of your worst case voltage, irradiance, temperature combination in that case. A final note on pvsyst. Not a lot of people know that, but pvsyst actually models a multi-MPPT inverter as two separate, or like a number of separate inverters. So let's say you have a 50 kilowatt inverter with 5 MPPTs. pvsyst would model it as at 5 separate 10 kilowatt inverters, which is entirely not true. That does not really reflect the real conditions at site and how the inverter behaves. Even PV system documentation says it is your responsibility to check in the data sheets whether the allocated power is compatible with the manufacturer's specification. So let's say a green light on your system data and pvsyst isn't enough. I would look at the documentation and specifically look at the manual as well, because not all the data is in the data sheet. And I'll leave you actually with a picture from Trina's launch event at the SNEC with our 110 kilowatt inverter. Thank you so much.
Thank you very much, Omar, for your presentation. Actually, you've got fans in the audience, so you have someone congratulating you on your excellent presentation. So I agree with Abdul. So thank you, thank you very much. As you know, as having all the presentations today, very interesting. So right, so we have a final poll, I believe. Is that right, Anna? So here we go. Yes, that means yes. So we have the final poll here, which is what is your usual project size? And the first option is less than 200 kilowatts, between 200 kilowatts and 2 megawatts, between 2 megawatts and 20 megawatts, and more than 20 megawatts. So it seems that we have majority of people in the audience who are developing larger projects of more than 20 megawatts. So let's let the poll run for a little bit longer, and yeah, I think we can start a countdown. So in 5 seconds or so, we'll stop. So let's do 3, 2, 1, stop. Right, so well, the most common project size in this webinar, at least, is more than 20 megawatts, 42% of the answers. So, right, so well, we only have like 10 minutes left, so let's jump right into the questions. And, you know, I have a question really regarding regarding hotspots. So, you know, with higher currents, is there any other additional risks of hotspots or junction box reliability issues? And that question is from Antonio from Trina.
Yeah, hello, thank you very much. This is a very interesting question. Of course, there is I understand the concerns of having this higher current in a single module. But if you see, first of all, if it's in the junction box or combiner box, what I see is that it was very typical to put 2 strings together of 9 or 10 amps, so together in a single MPPT. That was very usual in the market. So now instead of 2 strings, you put one together. So at the level of a combiner box, that will be no problem. Inside the module has been designed to withstand the current. So there is, and it goes all the tests that safety, the 61730, it has gone past all those tests. So it's as safe as any module that has been before. Any more concerns? Apart from having having the all the certificates, that having the best sell in the market, which is that has been done with non-destructive cutting, which means that it's as strong as a cell. It has another thing. Now, then, if you see the number of diodes that you will find in the strings, because there are more modules, there will be many more bypass diodes, and this is also the number of bypass diodes, and the voltage for each diode is related to the risk of hotspot. So having more diodes on the string reduces that risk. But very clear, the most important thing about hotspot is the quality of the supplier. So in this case, if you go, I mean, of course, solar is will be a preference, but if you go for tier 1 supplier, there will be no, the risk will be much slower. The quality is key. So so summary, there is no more risk of hotspot with this module that any other size of module, any other size of cell is at risk and is compatible, and there are no higher risk of fire or anything. It's the same. Of course, go to a tier 1 supplier.
Thank you very much, Antonio. And there is a question for Omar, which is regarding, we had it here, I think you have answered it. And because all of the other questions are about people wanting to get in touch with all three of you. So, well, of course you can. Some of you have already given your details. But well, let's have a question for both you, Omar, and Steve. So, what's the next then in the development of high capacity modules? So we have seen, I think, Omar, you show that chart that showed how the capacities are getting higher. So I suppose inverters have to evolve as well. So what's the next step?
So, and I mean, should I go or?
Please, yeah.
First? All right, sure. So in terms of what we have today on the market, I think our solutions that we have already in the market that have been for the past, let's say, 5-6 years are already compatible. So the short circuit currents, we are able to handle. The operating currents, we're able to handle. So as of now, the situation is, let's say, under control. Of course, we're looking at our teams in R&D are looking at the latest developments in the module world, and we'll make sure then to match basically this current capacity, short circuit current and operating current for the new generation of modules as they're introduced by the manufacturers.
Thank you, Mark. Steve, what do you have to add to this? So what's next in the development of inverter technology to match, the evolution of modules?
Yeah, thank you. So I think we are also keep following with the China Solar team for the product development, and also for this for today, like the 600 watt. Also, it is like 2 years ago we are cooperated with the China Solar to do it. So from the inverter side, so the module, the current is higher. So this is also can reduce the LCOE of the whole PV plant. And for the inverter, now we are doing for the inverter for the next 1 year to next like 5 or 6 years. So this inverter, it is compatible for the next like the generation of the older modules development. So for Huawei, our inverter is just like one inverter fits for all. It means so from the different kind of the current. So one product we wanted to cooperate and also combine with them together. So this is what is our strategies.
Thank you very much, Steve. And well, my follow-up question is regarding the balance of systems. So, with high current modules, is there any do costs on the balance of systems increase? For example, my understanding is that cables would have to be of a different specification. So is there an added cost in terms of balance of systems of using ultra high power modules?
Yeah, based on our team, we are analyze that, like the cable quantity, it can be reduced. And also it is can maximum to use like the 4 square meter of the capability of the cables. So definitely for the cable side, the BUS, it can be reduced.
Right. Thank you, Steve. Antonio, I don't know if you have anything to add.
No, I mean, it's similar. At the end, when you have to compare, that now you are putting one string in the place of 2. So before you were installing 2 cables of 4 millimeters, and now you have to install 1 cable of 4 millimeters. So that is the obvious way to see where is the savings.
Right. Okay, good. Well, the following question is from, it's on the chat, but we'll let it go because, well, it seems like a good question. So do you think that silicon semiconductors have space in the future of PV inverters? which would be the advantages of using these kind of semiconductors in your inverters, or SiC? Sorry if I. So I'll ask the question again.
Okay, I think already now for our inverters, it already have the silicon of the semiconductor already is inbuilt in our inverters. So like the IGBT and also some diodes.
Yeah, I think what Luis is referring to is silicon carbide technology on the IGBT stack level. We've already, of course, looking into that on string level, string inverter level. But as far as I know, we are already using silicon carbide technology on our central inverters. So our stacks, please don't quote me on this. I'm not 95% sure, but I'm pretty sure silicon carbide is already integrated into our stacks at the central inverters.
Okay, thank you very much. Well, I think like all good things, these webinars must also come to an end. We are approaching the end of our allotted hour. So, you know, I'd like to thank our speakers, and I'd like to thank everyone who's been with us here as well, you know, watching the webinar. So would you like to say anything to our speakers, to our viewers, sorry, before we leave? Let's start with you, Steve. Any parting words? Or maybe, yeah, okay.
It's okay.
So do you have any parting words for our viewers? We are leaving, we're finishing the webinar very soon.
Okay, I think it's for me, it's okay. Yes, but it's also is thank you very much for this kind of joint like discussion, and for the inverter, future inverters, and also the panels. So what is our effort is to reduce the BUS and also increase the generation, and it's better for the LCOE reductions. Yeah, this is our the joint efforts.
Thank you very much, Steve. Omar, any final words for our viewers?
Well, from my end, thank you very much for tuning in today. And please don't hesitate to reach out to one of our application engineers throughout if you need any assistance. And we'll definitely keep in touch via Trina, via ATA Insights. Thank you for having us today.
Thank you, Omar. Antonio.
So thank you, everybody. Thank you, Atta, for organizing this. I would like to just remark that, of course, this is a new product, a new way to think, and have to be studied to be implemented. We in Trina Solar, we are really eager to support any project that you may have. We have a group of engineers that can really help you to optimize the plant, because now it's a bit more confusing. We have different sizes of product, different cell size, different currents. So we have a team that can really help to optimize your product. We are please write us, and we are really here to support you.
Thank you very much, Antonio, Omar, and Steve for today, and thank you to all our viewers. So if you like this kind of webinar, go to atainsights.com and you'll see more of them. And right, well, thank you very much, and until next time. Goodbye.
Thank you.